Back to another video dedicated to physics. We continue doing straight line motion. It's all about relative velocities. So I've prepared a very interesting problem for you guys. Let's have a look. You have an escalator, you have a human being or basically a passenger moving down the subway from point A down to the point B. Escalator is moving downward as well. So read the question, read the statement in this problem carefully and try to do by your own. So this is all about the concept of relative velocity. Make sure you remember how to work out the resultant relative velocity, and let's get started. First, try to do by your own, and let's see my explanation. Alright, so we have an escalator moving down, and it takes 60 seconds for a passenger to cover the distance when walking down a long escalator with some speed or with some velocity. As passenger, we can mark as VP, let it be velocity for the passenger, and let's mark velocity of their moving escalator down from point A to B. So that's red arrow indicates their direction of escalator. So, and right now we can complete their equation just for distance from A to B. So let's mark this distance as D. So I mark first AB, and let's calculate using the idea of relative velocity. So if V passenger is velocity of passenger when escalator or relative to the escalator, on top of that we need to add velocity of the escalator. So that means we have VP plus VE. So we already add algebraically those two vectors, and times time. In this case, it takes 60 seconds. So that means we times 60, and that's how that's our estimation for covering distance D. All right. So let's complete another equation. If the passenger walks down twice faster, it will take 20 seconds less. So means right now we have the same distance. We have an idea that the velocity of the passenger is twice more than the previous one. On top of that, we add VE, the velocity of the escalator, and because it takes 20 seconds less, so actually it takes 40 seconds to go. All right, so let's move next one. You need to find how much it takes for him to cover distance when staying on escalator, which moves down, of course, with the same VA velocity. So what it means now, when staying on the escalator, the velocity of the passenger basically is 0 relative to the escalator. So that's why we left with VE, velocity of the escalator, times time that we want to figure out. So finally, that's time that we want to find actually. So how much it takes, we need to define that time so we can express time, make time as the subject. That's simply D over VE. So our final goal is to express distance over VE, and we can solve the simultaneous equations. Okay, so what we're gonna do, we equate distances. That means we can say that 60 times VP plus V equals to 40 times double VP plus VE. Okay, so right now we cancel by 20 and expand the brackets simultaneously. We'll get, so by 20, 3 VP and 3 VE equals 2. So here we have 20, so that means 2 times 2 is 4 VP plus 2 VE. And right now we need to express, let's say, VP through VE. If we transfer, we'll get that VP is equivalent to VE. So basically, your passenger, so the passenger is moving down with the speed of the escalator. But we don't know that. We can plug in any equation, either first one or the second one. So let's assume that we put in the second one. So that means we'll get that distance covered is equivalent to 120 of VE. All right, from where we have the ratio D to VE equals to 120. Because our time in seconds, we exactly know that time required to leap down from point A to down to point B using just staying on the escalator, it takes 120 seconds. So that's the answer. That's the answer for the question. So make sure you have the same, and I hope you're pretty strong in solving simultaneous equations, because all physics is based on creating equations and trying to solve them simultaneously. All right, hope you like that. That was pretty short. It's all about relative velocity concepts. Make sure you watch the previous video dedicated to finding average speed. It's also interesting questions and problems. And see you next time.